It's awesome to be down here in Miami.
Oh yeah, maybe go to Little Havana, eat some Cuban sandwiches.
Yep. Work trips can be fun sometimes,
Yeah.
you know? Oh, it's pretty cool just seeing those ships actually up close. They're huge.
Oh yeah, totally. I stood next to one. It felt like I was standing next to a mountain.
Yeah. It's like basically a whole city on board. It's really, really cool. It's starting to become smart cities.
Floating smart city, man.
Yeah, it is.
Driving every corner of our global economy is code. In this series, we look under the hood at today's most dynamic open source software with the people behind it.
There's data coming in from all different parts of society. Being able to have sensors there and really start to learn and leverage that is super interesting.
Computer vision is now something that we can use, and it gives us the power to make our cities smarter.
Miami, Art Deco architecture, sunny beaches, innovative design. It's a hotbed of color and modernism. And where art thrives, so does tech. Royal Caribbean is redefining technology's place within Miami's rich entertainment sector.
And we're building a new ship every year for the next decade.
We started about 2.5 years ago trying to rethink how we could use technology to disrupt our guest experience and our crew experience.
In this episode, we get on board with the innovators who are dreaming up our next adventure and go behind the scenes with the developers who are building these experiences.
We really rely on our devs. They're heroes in helping us find solutions to our very unique problems.
When you're out in the middle of the ocean somewhere, it's hard to get people on the phone to go in and fix it.
I want you to be able to walk up to your stateroom and the door just recognize you through sensors and the door just open.
This is Decoded.
I won the job lottery. I have the best job in the world. I get to create experiences for our guests and crew along with some really brilliant people here at Royal Caribbean. The technology, we hope, fades into the background to create our experiences. John, welcome to the Design Lab. Situated right in the heart of Miami here at the port, at this wonderful location that really draws on the inspiration that Miami gives in terms of architecture and design. In fact, maybe you've heard it said every company has to be a technology company today, but every company also has to be a design company.
Yes.
And we start those design processes from architecture, interior design, shipbuilding, all right here in this part of our lab.
And so what are all the skills that go into the design of one of these giant ships?
Oh, it takes a village, a really huge cross-functional team from design, interior, industrial, graphic, shipbuilding to technology. Think about our development teams, our architects, all coming together to imagine and build what hopefully is an amazing experience for our guests. I'd love to give you a sneak peek at some of the things we're dreaming up down in our makerspace downstairs.
That sounds great.
Let's head on down. The ship is so large, what might not be obvious is that we're really lots of companies operating together simultaneously to make this guest experience. Food and beverage, hotel, logistics and supply chain, design, and of course, technology. John, welcome to the makerspace part of our lab.
It's pretty cool.
It's actually my favorite part. The lab sits somewhere between Willy Wonka's chocolate factory and Tony Stark's lab. Everything that we do for our guests and our crew starts right here.
This is called the Innovation Lab. Well, how do you think about innovation?
Yeah, I sort of hate that word. Innovation today means everything and absolutely nothing. It's so overused, but we define it as the relentless pursuit. We're continually inventing and reinventing what products and services look like, laser focused on our guests and our crew.
Now, sometimes when people are developing software, they think about the agile process and they'll have their customer stories and do something similar. But I think you're taking that to the next level.
Yeah, exactly right. So we certainly work in an agile way when we're ready to go to production, but way before then, what should we produce and for who and why? And what should the experience look like? How do we define that? And that first prototype is maybe a little different than most people because we're not trying to prove technical feasibility. We're trying to prove desirability. Would a human being out in the world find this useful or interesting or entertaining, for instance? Josh Nakaya, who leads creative on my team, can walk us through the prototyping stages. Josh.
John, what you see before you is the process for our facial recognition unit.
Yep.
And as we went through this, we start with very low fidelity models. So at first, we're trying to figure out what is a desirable thing to do. So This is going to be one of the first things that greets our guests on their cruise experience. So we want it to be friendly. We want it to be at the right height. It needs to be both ergonomic and functional as well as friendly.
And so you could actually try this out with people and see how they react.
That's right. You know, it's like when people see things on paper, you know, people have different senses of scale, right? And what things feel like once they're in physical 3D space. So when we build something, we can show them, it'd be about this height, it would be this sort of form and this sort of stance it would have. And so people have very strong reactions when they experience something in person rather than just seeing a drawing or a rendering of it.
Cognitive services helped us think with our hands. So this is a demo of something we're doing on our ships to measure guest behavior. So we're not looking at faces in this particular instance, but we're measuring that there's a human being in the scene to look at dwell time, the density of people, and the direction they move. And just with those 3 data points, you can see Josh here, we're 99% sure it's Josh, just using a web camera. So we're using the onboard cameras we have, the CCTV cameras that are in public spaces.
Just adding intelligence to the existing system.
Exactly right, and just a little bit of intelligence helps us make really smart design decisions. So we're actually looking at all those data points to reimagine the way we design our ships to fit natural guest behavior.
You've got really an extraordinary platform to do this innovation.
We really do. With so many guests, it's really important that we understand guest behavior, guest movement through a vessel this large. That's what we mean when we say dwell time, watching how long guests stay in a section and move through sections. And we take that data to redesign our ships, bring it back in, and watch the dwell time change so we can make the experience as fluid and seamless as possible.
I thought it'd be awesome to get together with a bunch of the developers here at Royal Caribbean who've been working on kind of that magic, that end-to-end experience and how to make it better. Christian, tell us a little bit about the venue analytics team.
We have different tracks. One of them is venue analytics, but we also have pretty important computer vision and video analytics track, where essentially we capture information from cameras or devices and extract useful information.
Now that's a project that we've been working together. So I've got some folks here from Microsoft who have been on the team, Dexter and Nick. Do you want to describe a little bit about this application that you put together?
The solution that we provided was basically an architecture that captured data frames from some of the existing infrastructure on the ship and piped that data to like these loosely coupled AI models. And what that basically means is that they can plug and play different AI models as their business grows or their business needs change.
Now, what kind of hardware does this run on? Because you're on a ship, you're not always going to have connectivity. How did you solve some of those problems?
We found during some of our testing that, you know, just a traditional CPU machine is really good for actually streaming the camera frames. When you actually go to run the machine learning on that, though, it starts to bog down. And because you're on a ship with only so many machines, you can't really scale that out. So Royal Caribbean's actually started to put some GPU machines on these ships, and we're deploying the solution in a way where the data captured from the CPU machines, from the cameras, are actually getting routed to a GPU fleet.
For the actual ML processing, we have an 8 GPU machine that is running Linux Ionic. So essentially, the way that the system was architected is that the CPU devices capture information and route it through that RabbitMQ cluster to the actual machine that's going to do the processing. Yep. And then there's a persistence module or an output module that throws that information either back upstream or to an internal system that we want to further process or maybe aggregate and do some analytics.
You work on this project, you come up with this novel way to handle the fact that it's disconnected and how are you going to do the testing, and you decide to open source it. Were there any other parts of the system that ultimately became open sourced or you think about?
Yeah, I mean, if you think about kind of the project, you know, at one point you have some inputs, in this case it's camera feeds, and on the other end you're sending machine learning outputs. The only part that's really proprietary to Royal is that machine learning part. So we thought there's a lot of this that we can open source.
How do you make sure that, you know, the right capture goes to the right guest?
Everything we do is completely anonymous. So we actually don't identify anyone. It's
because it's more for analytics, right?
It's for analytics.
Like,
and it's
how long the line is.
Exactly.
Yeah, exactly.
And it's really people counting, and you would think that the algorithm would actually count everyone, but it doesn't work that way. It's density-based model. So it doesn't count people. It estimates density of people within the image.
I know sometimes in the ship and there is a show happening, people just get crowded there, right? I can see like always, and if I go with my husband, sometimes he's still like, let's avoid that line, right? I don't know if it can be enhanced.
And this algorithm is specifically designed for that crowd measurement.
Yeah, but there is data about people flowing through the system. You must have, do you think about the privacy aspects of this?
Yeah, absolutely.
Yeah, actually, at Microsoft, that's a big concern, right? We try and make sure that we cover those concerns. And on every step of the project, what we did is we made sure that the camera frames that were flowing through the system were encrypted. And we built a component that basically continuously runs and deletes camera frames from blob storage.
So Nick, when you were sitting down and writing the actual code for this, like what tools did you use? How did you go about putting it together?
The project is mostly written in Python. Python is great for machine learning, for computer vision. There's a ton of great open source libraries. So we really wanted to stick with Python just to make sure that there's a little bit of consistency in the project. The team at Microsoft hadn't had a ton of experience with Python, so we decided to kind of start by making it extremely difficult for ourselves. Really going hard on like linting rules, trying to use type checking wherever possible, so that we can catch the mistakes that we make when we do refactors and all that. And also when we have other people contributing in the future, potentially for the parts that we open source, we can really keep that high quality bar with the strict guidelines and really focus more on building the right thing and letting the tooling check when we make a stupid mistake. We were using Azure DevOps for our project planning and to actually host our code base. We had a YAML configuration for a build pipeline that would kick off every time we push a commit. So like our development flow is, we can work on our own Git branch. When we're ready for a PR, we create one in Azure DevOps that will kick off a CI/CD build.
But do you guys have any code coverage thing that will block the certain percentage? If it doesn't make it, then the CI will break?
We do, yeah. So when you write an IoT Edge application, you have a bunch of different components. So they're actually just different modules. They build in different Docker containers, essentially. And each of those we actually set up code coverage rules for. So during that build process, we run our unit tests. If any of those fail, the build fails. But after that, we actually go out and pull the coverage reports, upload them to our pipeline results so you can see it visually. And also, if any of that code doesn't meet the threshold that we agreed to as a team, that will fail the build.
Recently in Jenkins, we had started using a graphical view, right? That was something we started using from last sprint, that it gives you a graphical view of how much time it took for building your unit test, the time itself. So it's a very cool thing in Jenkins.
I've heard an amazing number of advanced technologies. Any favorites that jump out? It sounds like containers is big, ML's increasing.
We're actually using serverless function in our project. So serverless, it's basically something you use when you have a piece of code that doesn't take that long to compute or doesn't need long compute time. And you don't want to concern yourself with infrastructure for such a small piece of code. So we ended up using something called Azure Functions, a service that Microsoft offers, and kind of employed that in our code base.
So I just want to say thank you to all of you and look forward to seeing what we can do here in the future.
Where most companies would go right to the cloud, we're running data centers on board our vessels that only sync to the cloud when we have better Wi-Fi, just the deltas. Problems like that are the types of solutions our developers have to solve as we dream up experiences in the lab.
All these trends, so you're using kind of some of the advances that the industry has made around machine learning and facial recognition. What do you think the next big technology transitions?
There are real practical issues to go work out, but the continued use of biometrics for boarding, payment, security, the list goes on. So the work with you all in our computer vision program isn't just about dwell time. It actually unlocks about 15 different use cases for both guests and crew in really amazing ways. Think of the flow of this ship. Today, typically, cruise lines do that by sending industrial engineers to go sit with a counter and understand guest flow. There's no reason that we can't get the benefit of computer vision to do modeling around human.
Combine it with location services, and you probably have pretty incredible data.
That's exactly right. And because we're a pretty hefty innovator in building new ships, we can use that data to better inform spaces that are heavily utilized, the flow of guests through spaces.
So it's been incredible to see how you've been pulling together all these pieces and really building that next generation experience for your customers.
Yeah, you've been great partners. It's been fun.
Yeah, I've really enjoyed working with your team.
Thanks, John.
Yeah. Now this.
Yeah, the magic carpet.
The magic carpet.
It's interesting to see how, each year becomes simpler to do even more complex things, just with different products and tooling that comes out.
I'm really excited. Like this project could really serve as a model for how you should actually design a city and make it smart and intelligent, and in a way that can just improve like pedestrian traffic, transportation, and kind of like just make people's lives overall better.
I agree. It's going to be really interesting to see, like smart cities evolve. Even just things like being able to detect if a bridge is going to fail, building that with sensors embedded in, things like that, I think are just going to become prolific in the coming years. And it'll be really interesting to see what kind of challenges and what kind of problems that we can actually solve.
I really like the open sourcing aspect of this project.
Yeah, that's one of the new things for me. It's nice to be able to actually get feedback outside of Microsoft on the work that you've done. One of the cool things about open source is that a lot of the real, hard fundamental problems of computer science are solved. And by open sourcing those solutions, you can actually pull them into other projects and really start to focus on, building something unique and bigger that might be more niche or might be more domain specific. So without those, common set of open source tools, you can't really do that. It's great that you can actually go and, open up the GitHub, see what the code is. If you see any problems with it right off the bat, you can choose to not use it, or you can actually just choose to kind of go in and improve it.
Open source projects provide a template for how other technical people and other software developers can contribute code to the world, and it makes it a lot easier for them.
Then it really does foster a community of just constant improvement to really make sure that things that we're writing are secure, they're scalable, and they can really work for all of our customers and not just one specific use case.